Today we're going to take a look at our last topic of the year, integration by parts. We're going back to section 6.3 from the textbook. Now throughout usually the end of Calc 1 and then the majority of Calc 2 focuses on techniques of integration. Use substitution is just the tip of the iceberg. Integration by parts is another technique. And we usually want to use integration by parts when we have a product. And use substitution just isn't going to work. As you can see in this case, if we let u equal x, du is going to equal dx, and there's no way to get rid of that cosine x. So even though there's no product rule or quotient rule or chain rule for integrals, this integration by parts actually comes from the product rule for derivatives. So let's derive this formula. So we're going to start with this notation here. So the derivative of a product with respect to x is just going to equal that uv prime plus vu prime. But instead of v prime and u prime, I'm going to rewrite this a little differently. I'm going to say u times dv over dx plus v times du over dx. And then what we're going to do is integrate both sides. So now I'll have the integral of the derivative of u times v over dx, and we still need to put the dx next to that, and then this is going to equal the integral of u times dv over dx, and then dx, plus the integral of v times du over dx. So now what's going to happen are all the dx's are going to divide out, so the antiderivative of the derivative of uv is just going to become uv, dx's divide out. Over here, we're going to have u, the integral of u times dv, dx is going to cross out. And then here we'll have the integral of v du, and again, dx's are going to cross out. And then what I'm going to do is switch some things around. I'm going to solve for the integral of u dv, so I'm going to move that over here. The integral of u dv is going to equal uv minus the integral of v du, and this is the formula for integration by parts. And we'll go back to that first example that I had. So pretty much this is showing us a product. We have something times another something, and we're going to separate this, and that's the part of the formula here, the technique. So let's take a look, but this again is what we want to remember. Now it is going to kind of be trial and error as to what we're going to let each part be. But again, we're going to start this off. I'm just going to rewrite the formula. We have the integral of u dv is going to equal u times v minus the integral of v du. So what I need to represent here is I need something to be u, and then I need something to be dv. We usually want to let u equal something that's going to have a very simple derivative. So in this case, let's just start with x. Let's let u equal x. That means dv is going to equal the rest of it. So again, this is the u, then this whole thing will be the dv, cosine x dx. So what I want to do with the u is I want to take the derivative. So we'll have du equals dx. I'll take the derivative of both sides. What I want to do over here is find v, because notice the parts. I need a u, I need a v. We're going to find v by taking the integral here. And then I need a du, which we have du as well. So v is just going to be the integral, and the antiderivative of cosine x is just going to be sine x. So I have a u, I have a du, I have a dv, I have a v. All of those are the parts to the formula. So now we're going to say the integral of x times cosine x dx. That's the u dv, integral of u dv. This is going to equal u times v, so that's x times sine x, minus the integral of v, which is sine x, and du is dx. So now, by using this integration by parts, I now just keep the first product the same here. And now I just need to take the integral of this. So the antiderivative of sine x is going to be a negative cosine x. And I still need that plus c at the end, constant of integration. So we get x times sine x plus cosine x plus c. Now here's a nice way to check. You could just use your calculator to type in this integral, or you could take the derivative of this answer and see if you get the x times cosine x. All right, let's try this one. Here we don't have an indefinite integral, we have a definite integral, so we have to be careful. Now typically when one factor is just an x, that's what we're going to let u equal. But again, let's go ahead and just practice writing out the formula. The integral of u dv is going to equal uv minus the integral of v du. So we're going to again let u equal x, and then we'll let dv equal e to the x dx. So this works out pretty nice, but I'm going to show you what if you switch this around. We'll take a look at that next. Sometimes it could work out just as easy. Other times it causes a more complicated expression when we go to use the formula. So now again we look at du, that's going to equal dx, and that's what we're trying to do with du. And v is going to be the antiderivative of e to the x, which is nice here because that's just e to the x. So now we have the integral from 0 to 1 of x times e to the x dx. So this becomes x, so u times v, x times e to the x. However, we still need to evaluate this as x goes from 0 to 1, minus the integral from 0 to 1 of v du. So now just evaluating, first we're going to have a 1, so we'll have 1 times e to the first, which is just e, minus a 0. So I'm not even going to write that. And then minus, here, antiderivative of e to the x is e to the x again, as x goes from 0 to 1. So we'll get e minus e to the first, which is e, minus e to the 0, which is 1. So we get e minus e plus 1, which is just 1. Now what if you tried this switched? So let's say if we let u equal e to the x and dv would equal x dx. Let's see how this would look. So du becomes e to the x dx, and then v becomes the antiderivative here is x squared over 2. And that's a little more complicated because if we were to write this out, we would have u times v, so we would have e to the x times x squared over 2 from 0 to 1, minus the integral of v, so we have x squared over 2 times e to the x dx, and that's just not nice. Compared to how we did it the last time, the first way was a lot easier, so we'll just kind of cancel that out. But as soon as you start to see something, if it's giving you this, so maybe you tried, if you thought of this first and you tried it, I would stop right here, maybe switch them around and see if it's a little bit easier. So in this case, we're just going to leave it be because the first way we did this was a lot easier. All right, taking a look at this next example. I want you to pause the video and write out what you think u is going to equal, and then dv, and then go ahead and find du and v. All right, and pause the video if you need more time. But like the last one, let's go ahead and let u, now it's not going to equal just an x, but it is going to equal an x squared. And then dv, that looks like the same from the last one, e to the x dx. So now du is going to equal 2x dx, and v is still just going to equal e to the x. Now it's still going to be a lot easier this way versus if we let u equal e to the x and dv equal x squared d to the x. Because sometimes we may have to repeat the process, and we could see, and you'll see this in a few more steps, if we had to do this one more time and kept taking the derivative, eventually we'll get a constant. So now we'll write this as the integral of x squared times e to the x dx. It's going to equal u times v, so we get x squared times e to the x, minus the integral of v du, so we get e to the x times 2x dx, and that's still okay. So we'll just kind of move that 2 out in front here. So we get x squared e to the x minus 2, the integral, I'll put it as x e to the x dx, And all we do is repeat the process. Sometimes we have to. So if we do that, now we're going to let u equal x, and now this is going to turn out nice. Then we'll have dv is equal to e to the x dx. So du is going to equal dx, and v is going to equal e to the x. We just have to be careful with our signs. So now this becomes x squared times e to the x minus, and because we need this whole quantity here, we're going to repeat the process. So we're going to have 2, actually we can move the 2 out in front, times the quantity, and we go through the formula again. So we have u times v, so we have x times e to the x minus the integral of e to the x dx. So now this gives us x squared times e to the x minus 2x e to the x. And then this is just minus, we'll get a 2 as well as we distribute, plus 2 e to the x, and then plus c. And again, you can check that on your calculator. All right, we'll take a look at one more example. And I'm also going to work this one out both ways as well, just so you could kind of compare to see if one, letting u equal 1 or the other could be easier. So let's start with letting u just equal e to the x. Then dv is going to equal cosine x dx. So now du is going to equal e to the x dx. And v is going to be the antiderivative of this. So that would become sine x for v. All right, so now we'll say the integral of e to the x times cosine x dx is going to equal u times v, so we had e to the x times sine x, minus the integral of v du, so we get sine x times e to the x dx. Now we have another product here, so we have to repeat the process. I'm just going to rewrite it a little bit nicer. We have e to the x times sine x minus the integral of e to the x sine x dx. So I like to just draw a line saying we're starting the process over again. So now this time u is going to equal, now since we let u equal e to the x up here, we're going to keep it the same, e to the x, and then dv now is going to equal sine x dx. So now du still equals e to the x dx, and v this time is going to equal negative cosine x. So now we're going to have, first term stays the same, minus the quantity because we have to repeat the process, u times v. So I'm going to write this as a negative e to the x cosine x, then minus the integral of v du. So we have another negative cosine x times e to the x dx. And we'll distribute these negative signs here. So we get e to the x times sine x. We'll get plus e to the x cosine x. Now originally this will be a plus, so then we need to subtract it again. So then we're going to get minus the integral, and I'll put the e to the x first, cosine x dx. Now we're still kind of in the same boat. We're actually back to what we started with over here, which means that matches this. So what I'm going to do now, I'm actually just going to bring this down. You're going to see something that can happen with some of these problems. We just have to look for it. If you notice, this term and this term are like terms. So I'm going to add this term. I'm going to bring this over here to the left side. So I'm going to add it to both sides. So now we're going to get 2 of these integrals of e to the x cosine x dx is going to equal e to the x sine x plus e to the x cosine x. Now we will put our c in, but after we solve for this. So now to isolate this, all we have to do is divide by 2. So this integral, e to the x cosine x dx, is just going to equal 1/2 of this quantity, e to the x sine x plus e to the x cosine x. We'll put in our plus c at the very end. Now let's try it the other way. See if maybe it was a little bit easier. All right, so now let's let u equal cosine x, and then dv will equal e to the x dx. So now du is going to equal negative sine x dx, and v is just going to equal e to the x. So let's see if this makes it any harder, maybe just about the same or any easier. So we'll have u times v, so we'll have e to the x cosine x minus the integral of v du, so we'll have a negative sine x e to the x dx. It'll become a plus the integral e to the x sine x dx. And we're kind of in the same boat, so we need to repeat the process again. So now u, because we let u equal the trig function here, we're going to keep the process the same. U is going to equal sine x, and dv is going to equal e to the x dx. So now du is going to equal cosine x dx, and v is going to equal e to the x. And we'll repeat the process here. So we have u times v, technically because it's a plus sign, I really don't need the brackets, but I just like to show you that we're going back through the formula again. So we'll have e to the x sine x. Now it looks like those terms are just switched around from the last way that we did it. And then minus the integral of e to the x cosine x dx. And it looks like we reached that duplicate again. So then we would have the integral of e to the x cosine x dx is going to equal e to the x cosine x plus e to the x sine x minus the integral of e to the x cosine x dx. And we're at the same spot we were the last time. So we would just add this to both sides. So we get 2 times the integral is equal to this. Divide by 2 and then put that plus c. All right, so sometimes what our last few examples have shown us, we need to repeat the process. So this assignment, you can start this today, continue it tomorrow, and then I will have the solutions up on Monday. So from pages 328 to 329, this set of problems here, ignore anything that says the slope fields. When you get to number 5, just rewrite tangent x as sine x over cosine x. Remember, you can check all of these using your calculator. And as I just mentioned, sometimes you have to repeat the process. Now on Monday, I'm going to give you guys a graded assignment that you'll have a couple of days to work on and turn in. I'm letting everybody in class work together, so feel free if you want to reach out to anybody else, either in class or remote. You could work with them. You could even let me know if you have any questions as you're working on the graded assignment.